Let's give John a warm welcome.
Thank you, Colleen, for that kind introduction and for inviting me to speak tonight. Actually, it's probably too kind an introduction. I kind of thought the story you may have heard about the Irish gentleman who died, and the wife and families in the front row, and after the tributes went on, the wife asked the eldest son and said, "Patrick, go up and check, make sure that's your dad there." So my research has actually been quite modest. I'm just a neurologist, mainly see patients with multiple sclerosis and some lab work on the side. The big professional pleasure has been working with patients with multiple sclerosis, and I'm grateful to them too for their patience with me. Tonight, I'm going to talk about an overview of multiple sclerosis research. That's an enormous topic, of course, and so to have some focus, I'm going to speak about the research which is occurring here in the state of Wisconsin. Of course, Colleen's already given my talk, so it'll be short. As indicated in the title, I'm going to talk about the contribution of Wisconsin to MS research. We'll talk about the researchers who've been mentioned here, but also in a very important way, the contribution has come from the MS Society and the leadership of Colleen, and all of you here who have supported it. So to start with, as already mentioned, there are a number of MS-affiliated clinics here. Marshfield Clinic, led by Dr. Lauren Rolak, St. Luke's by Dr. Bhupender Khatri, Aurora Bay with Dr. Merle Thiessen, the Pro Health Care Center with Dr. Samuel Smith, Fredericton Medical College of Wisconsin by Douglas Wu, and our clinic where I work with Mike Withers and Chris Luzio. It's worth pointing out, too, that there are a number of outstanding neurologists in the state who do all kinds of things, and MS, including Dr. Lori Lobeck and Dr. Eric Maas, who've been on the CAC committee. Also, I should say, these first two clinics, particularly Marshfield Clinic and St. Luke's, have been at the forefront of enormous clinical trials which have led to approved drugs. Also, there are researchers, as you've been told, who work here in the state. Many of whom are here tonight. This is just a partial listing. Dr. Bill Chu, who worked on potassium channels and now mitochondria. Dr. Bonnie Dillel, who's worked with animal models of multiple sclerosis, and particularly microglial cells, which are very, very important. Dr. Colleen Hayes, who's worked with vitamin D, you know. Dr. Alexander Ng, who works with exercise physiology. Dr. Michael Crithers, who works on microglial cells, sodium channels, very important things to improve the function of multiple sclerosis. And I neglected to add Dr. Julie Olson, who's an expert in innate immunology. And my apologies if I've forgotten other people who are funded by the MS Society here. What I'd like to do is tell you about three examples of research projects that are underway at the University of Wisconsin, simply because these are what I know about and time is limited. There are many others that you could have a whole talk on. Because of time limitation, I'm just going to mention the details of this very briefly. Recall when he was speaking about long-winded sermons, Cardinal John Newman reportedly said, "No souls were saved after the first 10 minutes." In addition, Colleen said that if I went over time, the hook would come out. And if you know Colleen, she means it. So the first project I'll tell you about is related to the Promise 2010. It is centered on nervous system repair and protection. Is led by Dr. Ian Duncan, who's here tonight. And this is really an audacious, amazing kind of concept. Instead of most of our treatments which slow down multiple sclerosis, the thought is here, we find ways to actually repair and reverse the process of multiple sclerosis. Another thing is that this was a very highly sought after grant. The monies in it were well over $3 million. Virtually all the medical centers in North America and Europe applied for this thing. 4 were granted in the world. And it's to Ian's credit that one of them here is in Wisconsin. The other in the United States is Johns Hopkins, to give you an idea. This is a big, big group, and there's groups within the groups. Just to mention some highlights, Ian, working with Dr. Fabre in immunology and their colleagues, developed an animal model where you can study an anti-inflammatory drug. They showed how it worked, how it slowed down the animal model, and that drug, minocycline, is actually a subject of clinical trials. In addition, the ways to transplant cells into these animals have been developed, and this leads the way to actually do similar things in human studies. Dr. Field, working in this project, has developed new imaging techniques that are very high-tech, next-generation MRI scans to try and show specific areas where there's been damage, but there could be repair, the potential areas you want to repair. And not only that, how you would see that the area is repaired. So essentially, the MRIs can tell you where to go, and then to tell if it worked in that area. And this work actually has been applicable to human beings, so it's prime time, it's ready to go. Dr. Shushan Zhang and people in his group have worked with embryonic stem cells, adult stem cells, growth factors, and have done some amazing work. One of his most recent experiments, I think, is truly fascinating. The problem with the lesions, the areas of multiple sclerosis, is that the cells that make myelin are damaged and lost, among other things. And then afterwards, the bad cells that come in to make a scar appear, the astrocytes. And what Shushan has been working on, since these cells are coming out, basically you have a lesion with too few good cells and too many bad cells. And what he's worked on is how to change the lineage as these cells develop and start to invade lesions, so that the precursor cells, instead of turning into bad cells, astrocytes in this context, turn into oligodendrocytes, good cells. So you go from the perfect bad storm to the perfect good storm. Now, this is still very basic research, but it's an incredibly ingenious idea, and I've oversimplified it, obviously, but it would be wonderful if things along this line worked. This is only just a brief overview of this large project, and there are 3 other groups in the world working on the same things. We'll meet in New York in January. The next project here concerns CCSVI, chronic cerebrospinal venous insufficiency. And this basically is a theory that was developed by Dr. Zamboni in Italy in 2009. And what is CCSVI? Dr. Zamboni's hypothesis held is that the trouble with multiple sclerosis, maybe the cause of multiple sclerosis, would be a blockage of the veins in the neck that drain the brain and the spinal cord. And so if you have poor blood drainage, there's pressure backing up, and possibly harmful substances get out of the blood into the brain and the spinal cord. And his initial findings were very, very dramatic. Subsequently, there have been other studies, some of which support Dr. Zamboni's hypothesis, others which argue that it's not correct, or this may be the same in people with and without MS. So, people and the MS community and the MS Society have a big problem. You have controversy. There's a brand new theory with striking changes, and we've got people who say it's true or isn't true. So what the society did is they had this rapid research response initiative very quickly, put together over $2 million, and looked for the best centers that would answer this question with the strongest science as soon as possible. The leader in this study is Dr. Field here, and there are only 3 centers that were chosen in the United States to do this, and one of them is Dr. Field's, to his credit. What he is going to be doing, again, is using very sophisticated MRI techniques to look at those veins. Some of these techniques were developed at the University of Wisconsin in radiology or medical physics. Some of them just not done in other places. And one of the very, very important things this study will involve is careful masking. That is, the scans will be done on people with multiple sclerosis, on people with other neurological disease, not multiple sclerosis, and on people who do not have any neurological disease at all. And then the scans will be all mixed up. They'll be read by radiologists, a series of radiologists, who don't know the patient groups. And this is really, really important so that the results are not biased, even unconsciously, by knowing what it is. So I think that Aaron's study will give a definitive answer. I want to just mention briefly, down at the bottom, another small study, actually funded by the Department of Defense, gives you an idea of how money from the MS Society can be leveraged to getting grants from other places. And this, Erin, will be looking at the earliest lesions of multiple sclerosis. That is to say, even before there's a lesion you would see on a regular MRI, before the patient has symptoms, we have ideas now that you can trace this back months, so-called pre-lesions, before it all happens. And if that could be done reliably, it would be wonderful. Because now you could look at a patient before the attack was going to come. You know it was probably inevitable unless you did something. But you could study treatments and therapies way back then, early, before the patient actually had attacks. So it's kind of a prevention strategy one. Finally, the work I'm doing with the helminth-induced immunomodulation therapy, Dr. Fabre thought of the nice acronym HINT, because it's a preliminary study. This is based on something called the hygiene hypothesis. Well, what is that? The hygiene hypothesis says that modern sanitation is a good thing. It's prevented all kinds of terrible diseases. Look at the cholera in Haiti right now. So we don't want to go back to the dark ages. However, in the hygiene hypothesis, and it's just one of the hypotheses that apply to the cause of multiple sclerosis, you look at the fact that multiple sclerosis, frequent multiple sclerosis, is a relatively new disease, and then occurs in developed countries. Now, there's a lot of other reasons for that, perhaps. That's due to genetics, UV, vitamin D, different viruses. But it's one of the hypotheses. And the thought is that, again, hygiene is a great thing, it's important, but throughout all of human history, virtually until now, and certainly during the evolution of human beings and their immune system, we've been constantly flooded with small infections, minor infections, which are usually not serious, but stimulate the immune system. And the thought is that if you take that away, as an unintended consequence, the immune system overreacts. So the solution is again, not to go back to the dark ages, but to find what we call probiotic therapies. That would be a harmless organism that you could give that would stimulate the immune system and help reverse these problems. If you asked me 10 years ago, I would tell you this is a crazy idea. I have stories to tell you about that. But there's actually a fair amount of basic science and immunology behind this, and some observational studies, therapeutic trials that have been done in inflammatory bowel disease, for example, at the University of Iowa, and an amazing study done by a very careful, good neuroimmunologist in Argentina who looked at his MS patients who were and weren't affected with minor gastrointestinal infections. And in the people that got an infection, the MRI activity of their multiple sclerosis diminished by 95%. Now that's something, we don't have any therapy, anything close to that. Never had a result like that. Now the trouble is that's an open study, they weren't blinded. It's an observational study, it was just looking at people in clinic. So that might not be confirmed at all. So after getting a grant from the Multiple Sclerosis Society in a long, long time working with the FDA, we started the HINT study. The organism we use, yes, technically it's eggs of a worm, but it's microscopic. I should have brought a vial. It's a little clear fluid. We're not allowed to drink it because of the rules, but the patients, 5 patients that took it, they were the first 5 patients in the world. It tastes like Gatorade because it's made for the right pH for that. And of those 5 patients, we just treated them for 3 months. It's a safety study. The MRI results and the clinical safety results were quite encouraging. Now we are going on to do 18 patients and study them